What's up, everyone? This is LeetCode 234, Palindrome linked list. We've done this problem in Python, now we're doing it in C++. So we have a linked list, and we have to check if it's a palindrome. Return true if it is, otherwise return false. Now, palindrome reads the same forward and backwards, right? So 1, 2, 2, 1, right? Read that backwards, that's 1, 2, 2, 1, so this would be palindrome, right? Now, the issue with this problem is that it's a singly linked list, so it's one directional. So it's not like you can check very easily whether it's a palindrome. You have to do some trick, right? And really, the trick to this problem is that you want to basically make use of the fact that you can reverse the second half of the linked list and compare the first half and the second half, right? And the way you do that is the way you solve this problem is a three-step process, okay? So number one, we need to find the midpoint. Number two, we need to use that midpoint to reverse the second half of the linked list. And number three, compare the first half and the second half of the linked list. Remember, the second half is reversed. And check, as we traverse the first half and the reverse second half, right, at every node, are those nodes equal? And if they are, so far we have a palindrome. If at any point the nodes are not equal, then we don't have a palindrome, okay? That's the gist of the problem. So I'll just show you in a comment here. So there's something like this, right? So we would use a tortoise and hare algorithm to find the midpoint, right? So this would be the first half. This would be, the second half. Then reverse the second half. So instead of 2, 1, we'd be at 1, 2. And then we traverse the first half and the second half, right? And we can see that at no point are these nodes, as we traverse along, different from one another. So this is a palindrome, okay? So let's do this. So first step would be find the midpoint, tortoise and hare algorithm. And if you've been following me doing the grind 75 list, then we have already encountered the tortoise and hare algorithm. If you're just randomly coming across this problem, then I recommend doing the problem called linked list cycle. That's where you learn about the tortoise and hare algorithm. But yeah, that's kind of the tricky part about this problem is you're combining two small little techniques. They're easy, but there are two little techniques. One is use a tortoise and hare algorithm to find the midpoint, and two is reversing a linked list, right? You know how to do those two things, you're going to be fine. But if you don't, then, either brush up on this algorithm if you don't know, or just do the reverse linked list problem. There's a specific problem for reversing linked lists. That's a good problem to start for step 2 if you don't know how to do step 2. Anyways, we're going to find the midpoint, right? So let's make the pointers, okay? And we're going to say while fast. That's on next. Now, if you remember in the tortoise and hare algorithm, the slow pointer moves by 1, while the fast pointer moves by 2, right? When we exit this while loop, the slow pointer should be at the midpoint. Okay. Now, let's do step 2. Reverse the second half of the linked list, starting at the midpoint, because the midpoint basically tells us where the second half starts, right? That's the point of finding the midpoint. So let's reverse this, right? We're going to set previous equal to null, and we're going to say while slow, right? Because we start at slow, the slow pointer, which should be the midpoint, right? We're going to have to store the next node in a temporary node. So we're going to say this, right? And the current node that we're on, the next one is going to be set to previous, which should be null, right? Because the end of the second half should point at nothing after it's reversed. So that this makes sense. And previous is going to be equal to slow. And the slow pointer is going to be set to temp node because we're going to move along and keep reversing, right? Until we're done. Again, this is reversing a linked list is really simple, but just do the reverse linked list problem on LeetCode if you don't know what we're doing here, but this should be simple. If it's not, then you can brush up on that problem and you'll be fine. So now we did step 2. Now step 3 is basically traverse the first half and the reversed second half of the linked list and compare the I shouldn't say nodes. I should say I think I said nodes earlier. We should say values, right? Because they technically are different nodes. You know, like object wise, right? Like this 2 and this 2 are technically different nodes. They just have the same value. So I apologize. I think at the start I said we're comparing nodes. We're not comparing nodes. We're comparing values. And we compare the values to see if this linked list is a palindrome. Okay. So we're gonna make this node called first. It's gonna start at head. And second one is going to start at previous. Now, let me go to an example, right? Well, we'll just do 1, 2, 2, 1, right? When we take this and we reverse it, right? 2, right? This 2 is going to be previous, meaning initially we have this, right? Right? Now we're going to reverse this, right? And this one is going to be the previous, okay? As we go along. Sorry, no. The last one we encounter as we're going along, that's going to be previous. So this is going to be previous. So basically, I know I'm saying it confusingly, I'm sorry. When we have this, right? This right here is going to be first, right? And this right here is going to be second, okay? And we're going to basically move this way. We're going to move this way and do the comparison, right? Compare first and second, right? They're both 1, so we're fine. Then we move first here, we move second here, etc. That's what we're doing, okay? So it's really simple. At least conceptually, right? It's really simple we're doing. So we're going to say while second. Now, why do we say while second? Okay. Let me give you an example. Say we have something like I don't know why my color coding is going away. It says saving on it. I think LeetCode's just slow or something. Anyways, let's say we have something like this, right? When we do the slow and fast pointer, right, our fast pointer is going to go 1, 2, 1, 2. Fast and fast.next still have pointers, so we're going to do 1, 2. We're going to be out here, so 3 iterations. So our slow pointer is going to be here, 2. The slow pointer is going to be here, so we're going to have this. Okay, this is our second half. Now, when we're going backwards, right? When we're going backwards, right, what we're basically doing is okay. Our first pointer is going to be here. Our second pointer is going to be here. Because remember, when we set the first pointer, we're using the entire list, right? We're using the entire list. We're setting it equal to head. So we're setting head, and we have this entire list to go through, but we don't want to go through the entire list. We only want to go up to the halfway point, which is why we're using the second pointer, because remember, this node right here does not point to this 2. It points to null, right? Right? Pointing to null. That's why we want to do while second instead of while first, is because we just want to stop at the halfway point. Okay, I hope that makes sense. I think I explained that okay. So we're going to say while second, okay? I'm going to say while second if first val, if first val is not equal to second val, at that point we can return false. Okay. Now if they are equal, then we just keep traversing, right? So we're gonna say first dot next, second dot next. We're gonna keep going. And if we exit this while loop without any problems, it means it is a palindrome. So at that point, we can return true. Also, sorry about the no color coding. I don't know. LeetCode sometimes is really slow, like the servers or something. So. All right, give me a second. I'm gonna reload this. I'm not gonna change anything. I'm just gonna copy and paste. So refresh the page. Right. Same. I didn't change anything. I just copy and pasted what we already had. There you go. Yeah, I don't know. The LeetCode page sometimes is really strange. It's not on me. It's on the actual website. But anyways, right? It worked, right? 3 steps, right? Find the midpoint, reverse the second half, and traverse the first half and the second half, and go and traverse at the same time and check the values, right? And that's how we see if it's a palindrome. So that's how you should think about this problem, is the steps, right? Boom, boom, boom. I think doing it like that is much more easy to understand the problem rather than thinking about the solution as like one cohesive thing. Just think about, how do we get from, you know, how do we solve this problem in steps, right? Step 1, step 2, step 3. Very simple. And you can solve this problem in different ways, but you have this constraint here, which is there should be an O of n time and O of 1 space, right? So that's why we have to do it this way, because we don't want to use any data structures. I mean, a linked list is a data structure, but I mean, like, you don't want to use an array or something that gives you a lot more space and a lot more overhead, right? But anyways, I hope this helped, and I'll see you in the next one.